Hey everyone, Justin Smith here for Laurier Economics. I'm here to give you guys a quick tutorial on how to do the Students Mastering Intriguing Testable Hypothesis competition using Excel. Now, I have two other videos on how to work with the data using R and Stata. I made this one for doing it in Excel because some of you, typically the first and second year students, will have not taken econometrics and don't have any real exposure to those programs that we use in the upper years. But fortunately, you can still participate in the competition using Excel. It's just a slight bit more complicated to do some of the predictions, but it's definitely possible. And so this video is meant to help you do that. All right, so the first thing you want to do is go to the website for the competition, justinsmithecon.github.io/econcomp. And here you're going to find the description of the competition, how it's evaluated, the timelines, prizes, and most importantly, the data that you're going to work with. Now, before I show you how to download this, I'll just give you a quick summary. It's the data comes from the Labor Force Survey, which is a survey that StatsCan sends out every month to about 50,000 households, and they generate information on the Canadian labor market. So what we've got here is 1 month's worth of the Canadian Labor Force Survey, and you're going to be predicting people's wages using all the other information that's in the data set. Okay, so down here what you'll notice is that there's training data and evaluation data. Okay, so these are 2 different months of the Labor Force Survey. The training data is used primarily for creating and testing your model. So training your model, right? So you're going to generate your predictions. You can check those against the actual wages to make sure your model's going in the right direction. Okay, you can tweak the variables you use to make those predictions and so on. Once you're satisfied with your model, then you're going to generate predictions you're going to use that model to generate predictions on the evaluation data. And this is sort of just a different month of the Labor Force Survey. And the major difference here is that in the evaluation data, there's no actual wages. So you're just going to generate your predictions. And then you're going to submit those predictions online. And in the background, it's going to compare your prediction against the true value, which is going to be unknown to you, and then spit out what's called the root mean squared error, which is effectively just the average error in your prediction. And the team with lowest root mean squared error is going to win for their year level. Okay? So since we're using Excel, what you're going to want to do here is download the CSV versions of the files. The DTA files are for Stata. Okay, so my suggestion is you right-click and save as. Now, just for the sake of organization, I suggest you create a separate folder where you're going to store all the files for the competition. So mine's on my desktop, and I'm going to call the folder, I'm going to store this in EconComp. And the training data here, you just want to add the CSV extension onto it and save. And while we're here, we're also going to download the evaluation data just so it's there. Add this extension. Okay. So now we've got all the data. Before moving on to opening that up and working with it, I also want you to go to the website, the Odyssey website here that describes each variable. So we're just going to click on this link here, and it brings you to a page with all the names of the variables in the data set. Okay, a label for them. And then over here under view categories, you can check out the different values that the variable takes. Okay, so for instance, in the model I'm going to show you in a minute, we're going to try to predict wages in part using the sex of the respondent. Okay, so if I click on view categories here, what we see is that the value 1 in the data stands for men, and the value 2 stands for women. Okay, so this is what they call a categorical variable, where there's 2 categories and they're given numbers. Okay, now it's going to be important to remember that these numbers don't mean anything in particular except that they separate between the 2 categories. Okay, And we're going to use that fact later when we generate the predictions. All right, and don't forget too that there's more than 25 variables in the data set. So you just want to actually scroll down to view 60 items per page, and this will let you see all of the variables in the whole data set. Okay, so this is going to be your reference for what each variable is and what the different categories of that variable can take. Okay, now navigate over to your training data set, and we're going to open this with, in my case, Excel. I guess you could do the same thing with, potentially Google Sheets or whatever the program is that comes with your Mac if you have one. But this lesson here is just going to be about Excel. Okay, so we got a big wall of numbers here. The first row is the variable names, okay, and these are going to line up exactly with the ones we saw here in the website that we just looked at. Okay, so recnum is the record number, it's the individual identifier. We just saw the variable sex is male or female, right? So it only takes ones and twos, as we saw before. And then the variable that you're going to be trying to predict here is this one, hourly earnings, okay? And this is in dollars per hour. So this person here, their hourly earnings is $24.22 per hour. Okay. Now, there's all kinds of different ways that you can generate these predictions. I encourage you guys to read up a little bit online and explore different ways you want to do this. What I'm going to show you now is just a simple linear equation, okay? So we're going to scroll over here, and I'm going to create a new column called prediction, okay? And I'm just going to play around with some numbers, okay? So let's say that the baseline person is going to earn approximately $34 per hour, okay? Now, suppose that I think that, the person's earnings is affected by how long they've been at the company. Okay, and there's a variable in here that tells you that, and that's tenure. All right, so you see tenure, column W is a whole bunch of different numbers, and these numbers look kind of strange, right? They're pretty big numbers. So let's navigate back over to our code book here on the Odyssey website, and we'll scroll down until we see tenure, which I seem to have missed. There it is. Okay, and the label here says tenure means job tenure with current employer in months. Okay, so now that makes a little bit more sense. Okay, so this person one here has been with their company for 86 months. All right, and let's just say that the longer you've been with the company, if you've been with the company an extra month, that gives you 5 cents for every single month. So you earn $34 and then 5 additional cents for every month you've been with the company. Okay, so 30.05 times the value here, tenure. Oops. And don't forget to put an equal sign if you're generating an equation. All right, so times this. Enter. Okay, so we've now predicted that person one earns $35.21 per hour. Their actual is $24.22, so it's pretty far off, but let's just roll with that. And if you double click, so if you select a cell and you double click on the little square in the bottom right hand corner here, that's going to fill down. Okay, so it's going to repeat that equation on all the cells below it, and it's going to move down. If you're referencing other cells, it's going to move down the rows sequentially, okay? So you could see here that this person's predicted to earn $35 an hour. That's 34 plus 0.05 times the 28 months they've been with their company, okay? And so in column AD now, we have our initial prediction, okay? And it's just as simple as that. There is our first prediction. Now, the models you're going to want to use are maybe a little bit more complicated. And they're going to involve variables that aren't necessarily numeric in nature. Okay, so these or the tenure here represents an actual number. So the number means something. It's the number of months you've been with your employer. Let's say that we actually want to, alter our model to take into account the sex of the respondent. Okay, so men and women are going to earn different amounts. So we navigate over here to sex. Now, these 2s and 1s, again, don't actually mean anything. These numerical values have absolutely no meaning, except they're just separating the categories between men and women. And we know that men is 1, women is 2. And when you're working with something like this, one strategy is to actually separate this categorical variables into a set of new variables, one for each of the categories. Okay, so what we're going to do here is just insert a couple of blank columns. I'm going to create a variable called male and another one called female. And now we're going to use some if commands. So if equals if this cell equals 1, then we're going to give the variable male the value 1. Otherwise, we're going to give it the value 0. Okay, so if F2 equals 1, comma, we're going to give it the value 1. If not, we're going to give it the value 0. Okay, so in this first cell here, it takes on a 0 because the sex of the respondent is 2, it's female. And we can fill down like we did before. And you see we have a series of 1s and 0s, and it's only 1 for men and 0 for women. We do the same thing over here. So if the sex of the respondent equals 2, we're going to give it the value 1, otherwise the value 0. Okay, and we can fill down. Notice that whenever this variable is 1, this one is by definition 0. Whenever this one's 1, this one's 0. Okay, so this is going to be convenient when we're generating our predictions in just 1 second. Okay, so what we're going to do is we're going to take our formula here and we're going to alter our prediction. Okay, so we had it as $34 plus 5 cents for every month. Oh, did I make a mistake here? Yes, I did. All right, so first of all, we're going to fix the mistake in our, this should actually be Y2. All right, we're going to fill down. So we're actually referencing tenure. Okay. So we're going to alter our equation here to subtract $5 per hour if the respondent is female. Okay. And we know that we've created this variable here equal to 1 for women and 0 for men. So if I reference this cell, right, sorry, if I minus 5 times the variable female. Okay, enter. So notice that when the person is female, it takes the value 1, and when the person is male, it takes the value 0. So for this person, who we saw is female because they took the value 2, okay, it's going to subtract 5 because the female variable equals 1. For the next person, the female variable is equal to 0, so this person is male. When we multiply this 0 value by 5, it's not going to subtract anything. Okay, if we do this repeatedly down the line, it's going to subtract 5 only for those values that equal 1, which is the women. All right, so I'm going to take this formula and fill down. All right, and here's my new prediction. So this is $34 plus 5 cents for every additional month of tenure, minus $5 per hour if the person is a woman. Okay, enter. All right, and you can make your model even more complicated here by adding more of these variables. Just keep in mind that when you're dealing with a categorical variable like sex, like province, like marital status, like education, you're going to want to break that variable into a series of what we call dummy variables, 0, 1 variables, one for each category in the variable. Okay? And you can do something similar to what we did here. All right, so let's just say that we're happy with this model. Okay, our model is $34 plus 5 cents per additional month of tenure minus $5 for being female. Now suppose we want to just check on our model to see how good it is at predicting your wages. So the way we're going to do this in the competition is to use the root mean squared error. So let's just create a new column here called error. And this is just going to be our prediction, so equals our prediction minus the actual value of earnings. Okay, so how far away is our prediction from earnings? So in this case, what we see is that our prediction is $9.08 above the actual hourly earnings. And we can fill down and see that, we're making various errors on each prediction. So this one's almost $16 above. This one's $45 below. This one was pretty good. Okay, it's only 5 cents off. The next one was only 25 cents off, and so on. Okay, so that's the actual error. What we're using in the competition is the root of the mean squared error. Okay, so let's generate another column here called the squared error. Okay, and that's this squared. Okay, we're going to fill down. And then finally, we're going to calculate the square root of the mean squared error. Okay, so this is going to be equal to the square root of the average of the squared error. So we're going to take an average of these squared errors. Okay, we're going to scroll all the way down here to the bottom. Okay, the average so inside the far brackets, we have the average of all the numbers in AH. So AH2 all the way down to AH 42,093. Okay, so that's the mean of the squared error, and then we're going to take the root of that. So the square root of the mean squared error. Whoops, what happened here? That's curious. Well, let's try this. All right, so there's we'll just call this the MSE then. And then excuse me. And then the RMSE is going to be equal to the square root of that number. Okay, so $17.82 is the average error that we've made across all of our predictions. Okay, either above or below. So remember that number, 1782. Okay, let's compare this against the model that we had the first time. Okay, where we just predicted with just the months of tenure. So we'll take away this -5 for being female. All right, and we filled that down. And now the root mean squared error has adjusted to 18.13. So that's worse. All right, removing the information about whether the person is male or female has made the prediction worse. So we want to make sure that we add that back in. Okay, so -5 times female. And then fill down again. And then we're back to our old root mean squared error. Okay, so every time you generate a new model, calculate the root mean squared error and keep the model that you generate with the lowest one of those. Okay, so let's suppose that we're happy with this. Okay, our model is 34 plus 0.05 times tenure minus 5 times whether the person's female. Now what we're going to do is we're going to open up the evaluation data set and use that model in this evaluation data set. Okay, so remember that one of the rules of the competition is that you have to name your official prediction in a very particular way, and this has to be called P hourly earn. So for predicted hourly earn. And then we just calculated our model as 34 plus 0.05 times tenure minus, well, let me actually go back here. We got to generate our dummy variables first. So you're going to create the variables for male and female. Okay, so if this equals 1, then the person is male, otherwise not. And then equals if this is 2, then female equals 1, otherwise it equals 0. Okay, so we generated these. Now going back to our prediction again, sorry for the mistake there, equals 34 plus 0.05 times the tenure minus 5 times female. Okay. Enter. And this generates a prediction of $40.01. Now remember, in this evaluation data set, you don't see the actual wages. So you can't personally calculate the root mean squared error. That's going to be done in the background when you submit these predictions. Okay, and let's fill down here. Okay, so now we've generated a prediction for everyone in the data set. The next thing you want to do is copy this. Okay, so select the whole column, copy it, and then paste back in with just the values. Okay, so what's going to happen here is that it's going to hard code these values into the cell rather than keeping it as a formula. And this is going to be useful because what we're going to do here is we're going to eliminate all of the columns. So we're going to submit our predictions. We're going to eliminate all of the columns except the 2 that we need to keep. All right. So now we have a CSV file with the record number and the predicted hourly earnings. And these are the 2 things we need to submit. So now that we have this, we're going to go File, Save As. Okay, and remember, one of the rules of the competition is that you need to submit your predictions using your team name in all lowercase letters with no spaces. Okay, so let's just suppose my team name is the Deadweight Losses, and it has to be a CSV format. Okay, so double check down here that we're submitting a CSV. So I save there. Okay, then go to the website for the competition. Under the submissions section, and then you could submit your CSV files here using this link. All right, so this should bring up the economics competition submission page. Again, the rules for submissions are outlined here. You want to go down to add a file. Okay, and go to browse, go to the folder where you're storing all your data, and pick the one that you just saved. So in my case, this is the Deadweight Losses. Open it up, and then it's going to bring you back to the submission page. Click Submit, and then you'll get a page showing you that your response has been recorded. And that's it. That's how you submit to the competition. So the website is set up so that it recalculates the root mean squared error for all the submissions at the end of each day. Okay, so when you submit, you're not going to be able to see your root mean squared error immediately. You're going to have to wait till the next day. And you can check right here on the leaderboard when the last update was for the competition. So in this case, that was today. And you can also check, where you are in the competition. So besides me, nobody's submitted yet. All right. Now, if you submitted and you checked, say, the next day and you don't see your new submission, okay, so note the date of the last submission here. Probably what happened was either the file name was named incorrectly, so it has to be exactly your team name in lowercase letters with no spaces, or possibly that you've accidentally named the columns incorrectly in your submission. Or perhaps you didn't use the evaluation data set to make your predictions, you used the training data. Okay, so it has to be the evaluation data because these numbers here are going to match up with another data set that's operating in the background. Okay, whereas that's not going to be true with the training data set. Okay, so if you checked all those things and you're still having problems, let me know, and I'll try to get to the bottom of it. Okay, and that's basically it. Now, if you have any questions at all about the competition, you just want to talk about your model or anything else, contact me here at jusmith@wlu.ca. Thanks very much. Bye.